So this will be introduction, so I find out who you are and why you're here. And if you like, you can talk about a metric that you like or a metric that you don't like or some project that you're working on involving metrics. There's a lot of us, so we will have to do this pretty quickly. To start with, my name's Brendan Gregg, hi. And I work on performance all the time. I'm here to learn what problems you guys are working on because I'm really interested in improving the world of metrics. And I just gave an example of one I like/dislike. So, start with yourself.
I'm Leanne Goldstein from the RAND Corporation. I've got an I/O bottleneck I'm trying to find.
Great.
So far, I don't know how, I don't want to go into a lot of detail right now, but I've got basically a system that Oracle Financials is bringing to its knees and it shouldn't.
An I/O bottleneck. I/O has always been the bane of performance for a long time because of the latency it introduces. Cool.
Yeah, we run these batch jobs and all of a sudden the percent busy goes to 100%, and the people who are trying to use the Oracle Financials applications get like response times going into the seconds. It's like, and I'm going, I don't know what to do with this. I've been through consultants and working with Oracle kernel engineers who don't seem to know what the hell is going on either. I got a reaction of, wow, that's a mess. It's like, yes, thank you, I know that.
So percent busy goes to 100%, huge response times. I like to, we all know what TCP.
I'm in pain, you know.
So yeah, I like to do traces of disk I/O at that point. So I wrote a tool called IO Snoop. It's on Mac OS X by default. You can run it. It's like, if you have a network issue, how many of you would just run TCP dump and then feed it into Wireshark, right? Very common debugging. If you have a disk issue, do the same thing with disks. You run IO Snoop, you get the dump of the disk events, and then you pick through that. Same reason you can identify queuing.
Here's the thing, I've been using dtrace tools as best I understand them. The only thing I haven't run yet is a flame graph on this stuff.
I'm actually giving a talk on flame graph soon.
Yeah, I know, I plan on being there.
Cool.
Let me just, a housekeeping note. The purpose of this video will be to release it to the community and eventually the public. If any of you do not want a camera aimed at you, tell me that. I am happy to comply. If you want a chance to review the video before anything goes public, I can arrange that to make sure you're all happy with what ended up being said before it's shown to the world. I am perfectly happy to deal with that. So just let me know whatever reservations you may have about being filmed, and I'm happy to deal.
Cool. Thanks, man. IO bottlenecks. Kent.
So only, it's disturbing. I normally go by Scar. Only my mother-in-law and my mom.
Okay, thanks.
So if you want to be, and Brendan, so you're in that fine category of women. So I'm Ken Scar from VMware. I work on distributed management systems. I think we have many opportunities for us. I mean, we do development of these systems, but we have also operated them to a large extent. And I guess our realization is that we need to have a broad set of metrics so that we can increase the understanding of a system. Like, you can only go so long on your intuition on a distributed system. So there's several challenges. One that we probably won't talk that much about today, but that is our current focus, is how to do tracing in a distributed system. And it really is the same as tracing in a multi-tiered application or anything that has multiple components throughout your network. So there's a good paper, or relatively good paper from Google, the Dapper paper, so that if you want to do tracing, that is a good place to get inspiration for how to instrument your code if it is your code. But also, I mean, if it is open source code and you're using it, I would actually encourage you to patch the code to get the instrumentation that you need. I think we did that with Thrift at some point. We wanted to use the interpreted languages for some of the servers that we had, and what we realized is that some of these RPCs took much longer than we expected them to take. And when we instrumented the code, we could see that there is queuing time that happens when an RPC lands on a server. So it just takes a long time before the server starts to execute on it. And I think it goes back to you end up in a situation where it takes longer than I expected to do. What do I do now? It is starting to ask the right question about the performance bottleneck or the characteristic that you are interested in, and that activity kind of start before you actually start dealing with the metrics itself. What kind of questions? I know we recently had a performance issue with mutex locks on directories. That turned out when you access things in that directory a lot, it kind of adds up. And you get that's it.
Thanks. Thanks, Scott. And Narayan.
I'm Narayan Desai from Argonne National Lab. I'm an old HPC guy. I've been working on trying to build on-demand cloud systems that have the performance profiles and utility characteristics of HPC systems. And so we're getting to the point, maybe over the last 6 months, that we're getting really concerned about performance. Specifically with I/O, we made an unfortunate decision to put SATA drives in SAS expanders. And so this, in the things that suck category, when you can't get visibility into things, right? The big problem in this case is that you have firmware that's trying to be helpful by not failing if it can possibly avoid it. And so you just don't get visibility into what's going on, and all you see is high drive service times, right? And so, so what we've started doing is preemptively pulling any disks that are looking even remotely slow out of our arrays and sending them back. And that's kind of work, but it's an unsatisfying feeling overall.
Same thing.
Satisfying.
Oh.
No, that's.
Is it breakdown?
This is a good week, right? But that's not the phrase I would use in other circumstances.
Cool. Thanks. Peter?
I'm Peter Nordhaus. I work with SCAR on distributed management of resources at VMware. And aside from the distributed tracing that SCAR was talking about, another aspect of the work that we do is that VMware obviously runs your workloads, or at least not all of yours, but some workloads that are not our own, which means that we need to figure out what they are doing to some degree as well. And ESX, VMware's hypervisor, exports a ton of metrics about the VMs that it runs. And the questions for us there is as well, we have thousands of metrics we can sample for all these different VMs running across different hosts. But should we? How do we track them across machines as workloads shift from host A to host B? How do we capture that? Because right now the state of the art is you capture metrics on a per host basis, and that's kind of it, right? You have some multidimensionality in there on a different level, but usually it's you capture everything per host. And what we're looking at now is, well, we have stuff that moves around, and how do we track these performance indicators not only over time but also over location? So that's
Filter better metrics and using that model for capacity planning in the future.
I'm Theo Schlossnagel. My background's in distributed systems, but about 3 years ago I started a startup that deals with telemetry analysis and monitoring. We handle about 100 billion telemetry points a day now and store them all. I guess run into probably the problems that everyone here sees because we have a very wide array of clients in a lot of different industries. So what I focus on is the storage of all those things so that we can power long tail visualizations of those, analysis, capacity planning, applying numerical models to them, and building out the infrastructure that can actually, crunch 100 billion telemetry points a day and make sense of it all.
Okay, thanks.
Hi, my name is Patrick Webb. I work for Cray Inc. My previous life, I was actually a visualization person at a university. I'm a fairly new hand to system administration. I've only been doing it a couple of years. Recently, I find myself primarily responsible for a Lustre file system and a customer that's a little sensitive to hiccups in its performance. So hopefully I can learn a bunch about metrics so I can tell a better story about what's going on, if things are going bad and why. But that's what I hope to get out of this workshop today. I have a secret. And he's got a secret.
Secret Mara.
Okay, thanks, Patrick.
Hi, my name's Vecina. I have most of my background's probably in batch scheduling for larger companies. I'm sort of interested in, I have a experience putting together KPIs, and I guess I don't have a lot of experience collecting metrics at a system level. And I'm sort of looking at what tools are available that I could use to collect and build KPIs for our company. I guess one of the metrics, one of my favorite metrics that we used in the past was if you have a batch system that's got a complex set of rules and fair share and preemption and a lot of things that can affect performance, how do you measure performance if users submit hundreds of jobs with different dependencies? So one of the things we did was after the fact, after jobs are completed, look at their run times, look when they started, when they completed, and then model what that would look like on an ideal cluster, an ideal HPC cluster, and compare the performance. That had problems with, that told us when there was a problem, but then investigating that, figuring out what the root cause was still a bit of work.
Cool. Thanks.
My name's Nathan Ola. My background is primarily in a wide variety of system administration kind of environments, but today I'm in an HPC environment. I do a lot with storage, so I'm always interested in finding out more metrics about storage, because access to storage and performance of storage and the impact of storage performance on your environment is got to be one of the top things that needs to have good metrics around it and good understanding around it.
I'm Michael Finn from PESHAR Research. So my background is also in HPC, but we're in the process of upgrading from something ancient, RHEL 5, to something slightly less ancient, RHEL 6, and in the process, and in that same time period, want to redo the way we're collecting our broader system level metrics and KPIs. And so I'm here for some of the metrics, but also how do we aggregate those and monitor those and what makes sense as far as generating business level decisions.
Thanks.
I'm Ken Reed. I work with a small company out of Denver called CookBank. It's primarily software development. My job is we're going from a physical environment to a virtual environment, so one of the things I want to do is try to help coach developers on system resources and getting a better understanding of what metrics to monitor, which is what I hope to get here. Will certainly help you with that.
Great. Thanks.
Hi, my name is John Moss. My background is mainly in support for the last couple of years, right down to domestic systems. My main interest in this class is to pick up as much as possible regarding metrics. We do a lot of remote hosting of our clients' environments, and the more I can get out of this, pretty much allow me to be more proactive. Not really trying to solve any particular problem, just trying to learn.
Okay, thanks.
Hi, my name is Lowen Iki. I'm working on infrastructure of streaming video delivery in Brazil. And I'm trying to improve the metrics in the video delivery.
Okay, cool. Thanks.
My name is John Roulard. I'm a systems administrator with a background that sort of varies, statistical process control in the photographic industry to Six Sigma and Lean and ambulance operations, as well as systems administration. And I'm looking a lot into how Six Sigma and Lean can be applied to solve problems in systems administration. One of the big things I used metrics for was discovering the one bad disk on my radar array that was putting performance in the toilet. The VMware cards actually have performance indicators, and I can see one disk was not getting a whole lot of bytes, but had everything queued for it. It's like, pull that disk. So, Ryan, as a matter of fact, it was a SATA disk. Mike?
Hi, Mike Zavarello, weird and wonderful backgrounds. I won't talk about it. Short version, I'm interested in metrics because I'm actually interested in monitoring. And metrics is an input to monitoring. Getting it right, getting the metrics right so that the monitoring can be a little more effective, less false positives, that type of thing.
I'm Laura. I work for Google in Ireland. The team that I'm on run primarily some large pipeline-based systems, and they're kind of multi-owned across different places. I kind of care a lot about system, more about application and certain system level metrics. So answering questions like what is the delay through the systems, also, and things like what kind of error rates are we having, where are things getting dropped. So there's also issues where so the inputs that we're getting are spiking over time. But so if we get this big sort of increase in the amount of things that we have to process, we kind of don't want to wait and just have a backlog. And so what we do is we do a lot of auto scaling different parts of the pipelines, so to try and process these spikes more easily. So it's all based on metrics that we gather. So for us, metrics are actually kind of a key part of how the system works, as well as just troubleshooting and kind of transparency type of.
Like you don't auto provision based on some bad metrics and spend too much money that you didn't need to spend.
Particularly if you get into some sort of like positive feedback loop, I mean, suddenly you've got this massive job that is actually doing nothing, or maybe it's making some other part of your system work less well because your massively auto-sized job is building something else. There's all sorts of fun problems.
And like someone does a denial of service attack, and now you're auto provisioning all these new instances. And not only is it costing you bandwidth, it's costing you hosting. So cool, good stuff. Thanks.
Hi, my name is John Looney. I work on cyber reliability team in Google, mostly on the data center automation side and the emergency access. So performance isn't a concern for me, amazingly enough. Historically, I used to run the storage team out of Dublin, the storage support, and we did a huge amount of metrics. I would spent over a month chasing down a performance problem that turned out to be a known bug in Linux, where ext2 would often have to load up to 128K of RAM if you asked for 4K off the disk. That wasn't aligned in the right place. And had I good metrics back then, yes, I could have saved a whole lot of time. I also decided while you were chatting to try out dtrace, and it crashed my laptop.
Yes.
When my laptop came back, it started playing some YouTube video, and I started playing it a week ago. So I have discovered that dtrace is experimental still.
Yes, sorry for crashing your laptop. It is still not production safe. I wish it was. I have to. I run on
Linux.
On Linux. That's right. Sorry, dtrace is not production safe on Linux. But like Theo and I use it on other operating systems, Lumos and OmniOS, 24/7 works fine. I would love to see it finished on Linux so that you enjoy the same reliability. But cool. So you mentioned ext4 bug.
Or ext2.
Sorry, ext2. Which is what I wrote down. Was there a single metric that you already figured out? It was this metric I needed that I didn't have?
Well, so it was more that I had two metrics that disagreed. How many bytes were being read off disk was huge. How many bytes were being read by the application was small. And I couldn't get the two to agree, and I didn't quite understand enough of the system to make that correlation.
I have a great section in my new book about that. It's the VFS level and the disk level. There's tons of reasons why things will be inflated, deflated, won't match up at all the different stuff the kernel does.
But I'm a big fan now of saying if there is one metric that you want, there may be others that will disagree and you need to know that. So had I just been reading how much my application was reading from disk, I would have thought I had plenty of disk bandwidth. But knowing that that because I had metrics for how much the app was reading and how much the kernel said it was providing, I knew there was a problem. Just couldn't find it.
Excellent. Got it. Thanks. Thanks, John. And
my name is Will Fraley. I work for Capella University, which is an online university in Minneapolis. We manage all the storage, all of the Unix systems as well. Our big issue is we've gotten really good at collecting all of this data. We have NetApps, we have Linux. We've gotten really good at funneling pretty much every metric we've got, whether it's Graphite or RD backend. But we're not good at presenting it. We're not good at mining that data and seeing what making good decisions based on that data for the business. It's almost too much, I think, at times. On the storage side, it's really good to have those metrics when there is an issue to go in, and we've got every piece of data about every LUN, every volume, things like that. But for us, the challenge is how do we visualize that, and how do we make that data more useful to the rest of the business.
Cool. Thanks, Will.
I'm Dave Rocks from Pandora Radio. I'm a lead systems admin, also a maintainer and frequent contributor to Graphite and contributor to Ganglia. I'm interested in doing more correlation of metrics and also using the presentation of metrics. Collecting them doesn't seem to be too much of a problem. Times it's too easy. You end up with too many things. And I'd like to have better ways to steer users to see what happened at the same time. If you have 20,000 different metrics, it may not be obvious that two things happened and they're related. They might be related by some fixed ratio, which would have found his EXT problem. It might be some variable ratio. I think that I'm kind of maybe not uniquely positioned, but I have an interesting insight into some of this, and that I don't have any sort of big academic background. I'm not very good at math, which makes if things aren't very obvious, I don't see them oftentimes. So I like to work to make things more obvious for myself.
Great. Thanks.
I'm Marcus Groff. I'm with Carbonite. Here mostly with interest in seeing how people are tackling virtualized and/or distributed systems and gathering metrics for a system as opposed to just like a physical machine.
Cool. Thanks.
Alex Brotman, anti-abuse at Comcast. We gather hundreds of metrics and we use those to determine how our platform is performing, et cetera. I guess I'm kind of here to see if there's a better way to present it and maybe if there are better things for us to gather.
Cool. Thanks.
I'm Patrick Cable at MIT. We work on systems in my particular area for hardware design and development, and also some space hardware as well. We have a lot of users running a lot of different applications that stress different indicators, CPU use versus memory use. Some are memory heavy, some are CPU heavy. So realistically, I'm here to try to find out what questions need to be asked and how to ask them.
Excellent, thanks.
I'm Corey Leadinghainer at Los Alamos National Laboratory. I work with the high-performance computing systems there, and Patrick runs one of my big systems. We have a lot of places where we can collect metrics and use metrics, and we're not doing it as effectively as we should have, or as we should be. Perhaps partially because we are not a company who's going to rake in more cash if we do a better job of using the metrics or collecting them. So it's harder to justify putting the learning curve into, like Theo was talking about, there's a big curve to using dtrace and putting all those pieces in, but it's a great thing to do. It's harder for us to justify that when we can't show on a ledger that this is what we got out of it. So stepping forward from that is what I want to do to really be able to make use of what we have and run the systems better than we currently are.
Cool. Thanks, Corey.
Hey, I'm RJ Bergeron here.
Sorry, I'm just
okay,
remembering.
I'm RJ Bergeron with Palantir Technologies. Currently, we are doing a job that I've been happy with for what we're collecting on metrics, but getting better use of the data and especially finding things where it's like, okay, well, if stuff like this isn't agreeing, then that's starting to point to a deeper problem, and what the metrics don't necessarily capture, but what they're trying to direct you towards.
Cool. Thanks. Caskey.
Hi. My name is Caskey. I work for Google, where I basically build monitoring systems. I'm on the team that provides the software that's used to basically hoover up the data that is then brought from all of our data centers worldwide, brings it together, and aggregates it, and tries to present meaningful information to other SREs and developers inside of Google. And I'm here because I want to see, I want to help, not help, but I want to see more of what can be done to make the monitoring situation better everywhere, because we have tons of problems inside trying to deal with the data volumes that we're working with, and I want to be able to share and understand how other people are solving those problems, because there's a lot of data out there, and getting it and processing and analyzing it is a hard problem. I'm not smart enough to do it.
Great. Thanks, Caskey. And Miss Deirdre, did you want to tell people who you are?
I edit him in all formats.